Good morning, everybody. It gives me immense pleasure to be a part of this August gathering, and it's an honor to be, try to present what FARO can deliver in terms of the technology that is on offer from FARO's side. I'll quickly dwell into the agenda of my brief presentation. That would be covering more or less about who we are, what all we do, followed by a brief about the evolution of land survey equipments, and an overview about the technology offerings from FARO, as well as the various application examples. Also, in the meanwhile, what I like to do is that, I have our scanner on stage here. So I like to do a scan while I'm doing the presentation. So by the end of it, you can see a live data as to which will enable you to understand how easily and how quickly you can capture the data and do all measurements. For this, I'll just ask my colleague to come over the stage and just do the start scan while I'm going through the presentation part of it. FARO was established in the year 1982, and since then, over the years, through extensive research and development, FARO has established itself as the world's most trusted source of 3D measurement, imaging, and realization technology. Technology from FARO permits high-precision 3D measurement, imaging, and comparison of parts and complex structures within production and quality assurance processes. The devices are used for documenting large volume spaces or structures in 3D, surveying and construction, as well as investigation and reconstruction of accident sites and crime scenes. World over, approximately 15,000 customers are using more than 30,000 installations of FARO equipments for their daily works. FARO's headquarters is situated in Lake Mary, Florida, in the United States. Our European headquarters is in Stuttgart, Germany, and we have our APAC headquarters in Singapore. Getting more into the survey aspect of scanning, as you all would be knowing, survey basically is a science and art of making all essential measurements to determine relative position of points. Used across multitude of engineering applications, surveying takes existing reality and maps it onto virtual reality through softwares and similar mapping systems. Surveying is known to be one of the world's most oldest professions, dating back to the 1980. Tools such as the Gunter's chain, compass, and transit was used to obtain distances and angles. Up until the 1990s, we still saw surveyors using instruments such as chains, vernier theodolites, optical theodolites, electronic distance meters, and semi-total stations for all measurement aspects of the survey part. With the advancement in technology, surveyors were quick to get onto the new arena in terms of technology which was on offer. Land surveyors quickly capitalized on the latest technology, and it helped them simplify many workflows and also increased productivity. Devices commonly used today in the survey arena would be digital levels, automatic levels, digital theodolites, total stations, global positioning systems, and now something called as a laser scanner. Laser scanner is fast becoming a very popular tool for surveyors due to technology advancement. Together with powerful computers and softwares available today, land surveyors can complete their task within a very short time frame and with the desired accuracy levels. This brings us to a very important question as to what exactly is a terrestrial laser scanner. A terrestrial laser scanner, or a TLS, is a high-speed 3D laser system which is used for detailed 3D measurements as well as for documentation. TLS uses laser technology to produce detailed three-dimensional images of complex environments, geometries within a few minutes. So, which brings us to another important question as to why this technology is so important. Just imagine, now, if I say, you need to collect 1 million points today, with the conventional kind of instruments which we are using, it might take around 15 years to collect 1 million points. The advent of photogrammetry really reduced it to around a year and a half. Imagine the same set amount of points can be collected using a scanner within a matter of seconds. So this is what the technology has on offer for the new breed of surveyors. This slide basically shows how the scanner is working, but since I have a live scanner on stage, I won't go into this. Laser scanners have been around the market for over a decade now, and early adopters who used the scanners got the advantages. They knew how it would benefit their line of work. But the problem with laser scanners of earlier years, around a decade back, was that they were extremely bulky extremely heavy. I mean, you needed at least 2 to 3 people just to take the scanner out onto the field and do your scanning work. They were goddamn extremely expensive as well, and it was extremely difficult to set up this thing. In the year 2010, FARO disrupted the marketplace. What we were able to achieve is that bring the size of the scanner to an extremely small level. I mean, this is equivalent to your A4 size sheet of paper. Extremely lightweight, weighs just 5 kilograms, which makes it extremely portable. And the major part was we made the scanner to be affordable. Affordable for surveyors to use, affordable for the industry to capitalize and get their ROIs as soon as possible. So that was primarily how FARO came into the market and saw the opportunity and delivered over the years. Talking more about the products that we have for the scanning market, we have two specific products, which is the FARO X series. We have the Focus X130 and the Focus X330. Basically determines the range of the two instruments. One would be a 130 meter scanner. The other is basically a 330 meter scanner. Talking more, getting a bit more into the technical aspects of it as to what are the parameters. The FARO scanner boasts of an intuitive touchscreen display. I mean, majority of all the functions can be controlled via the touchscreen. It has got an internal integrated camera, which gives you a photorealistic depiction of the exact scenario, what is there on the ground. In terms of data management, we use a standard SD card, so the data transfer capability becomes extremely easy. Extremely small and compact, as I said earlier. And it boasts also of an internal lithium-ion battery, which can last for almost 5 to 6 hours of continuous usage. So primarily, which means that for any kind of survey work that you're going to do, the one battery can last. And also you have an option to have an extra battery as well. Talking about the range, as I said, we have a range within the scanner of up to 330 meters, which is primarily a radial range. The scanner has a capability to scan even in bright sunlight. Earlier scanners had a problem in direct sunlight where the laser pulses were affected and the range got drastically reduced. But with the advent of the Focus X series, now we can very surely say that, I mean, even in any kind of environments, the scanner would be able to deliver, as we say. The scanner also boasts of an integrated GPS receiver, which basically helps in the registration process, whereby you're taking multiple scans and provides the exact time and location of the user scans. And with the increase in wavelength that we did in the last product update, we are able to get results which are the scan results, which are more or less completely noise-free. In terms of the area which the scanner can capture, it captures a 360 reality around it, and on a vertical scale captures almost 300 degrees. With a ranging error of 2 millimeters and a measurement speed of almost up to 1 million points per second, the FARO scanner is one of the most attractive and the most efficient on-field laser scanning solution in the market today. This is one example that you're seeing where the FARO scanner was used to scan a bridge which spanned almost 900 meters. And this whole process of scanning and getting the deliverables, the scanning process took around 1.5 hours, and all the number of scans that were used for this particular bridge was, we used 9 scan positions. As you can see, the height of the bridge was almost 100 meters, and from a distance we were able to capture this data. And I'll just show you, this is the point cloud rendition that you're seeing on the screen right now. And everything that you're seeing there is accurate to 2 millimeter level, and it can all be, you know, this is all point cloud, so you can measure every aspect of what you're seeing on the screen right now. This is another example where the range capabilities of the Focus scanner are showcased. You get very good data up till 330 meters, which is what we say. And even after, I mean, because of the extended capabilities of the scanner can measure up till 480 meters, as you can see, I mean, depending on what you're scanning. So the range, we have put it in a conservative scale that we say that our scanner can measure 330 meters, but technically, I mean, it can actually go much higher than that. And all these scan distances that we are talking about are on a radial distance. So diametrically, I mean, you'll get much more ranges from one single position. The scanner, the Focus scanner is made for harsh environments. We already have people who are using for in underground mining, for tunneling applications. So actually it can withstand all these environmental conditions and can be very effectively used because it's portable and it captures the data at a much faster pace. What we are talking about is any single scan can hardly take around 3 to 4 minutes. As you would see, we had started the scanning while my presentation was going on. So the scanning is already done. So we will actually show you the data which it has captured from, I think it just took around 3-4 minutes for doing that. Talking more about the scanning workflow. The scanning workflow primarily involves doing a project preparation, doing a scanning, registering, and getting into the 3-dimensional deliverables. You can create the project names either on the device or before going onto the field. You can create these project file names on your workstations. So in this example, we are primarily creating the project names and all the user profiles on an SD card. So what you do with the SD card, you plug it inside your workstation, you create project names, file names, user profiles, and you simply have to take this SD card out and plug it inside the scanner. And once it is inside the scanner automatically recognizes the projects which are created, and you can directly go about doing the scanning aspect of it. So what the time you're actually saving is the on-field time to create, separate positional data that you have to enter. You can save all these times. So when you go to the field, all you have to consider and do is just place the scanner at specific positions and do all your scanning needs. Once the scanning is done, you come back to your office, simply take the SD card out of the scanner, place it into your workstation, and with the FARO Scene software, which comes bundled with the hardware, the software automatically downloads the scan data, automatically creates project names, automatically creates clusters for sub-projects, and does the post-processing and registration for you. So if you have taken multiple number of scan positions, what you get is from the software part of it is, and automatically you get all the stitched data together so that you can see a unified image. And from here on, you can export this data into different kind of CAD platforms where you can do your accessing part of it. Now, this FARO scan data is supported by all major software companies. Probably, you can take this data to Autodesk, to Geomagic, to 3D System softwares. So you name a software, the data compatibility is always there. So you don't have to worry really about, am I going to get stuck up with one single software? So the data operability is always there. The scanner is also used for diverse applications, from architectural, civil engineering to BIM, forensics, forestry, heritage preservation, films and movies, process industries, for surveying, shipping, tunnel and mining, gaming, 3D modeling. So these are just a few of the applications that I've listed here, but there can be multiple applications. Wherever you need an accurate data, the hardware provides you, you can do wonders with it. From the survey point of view, the major application would primarily be doing as-built survey, monitoring, topographic, calculating volumes and areas. These would be the primary application when you talk about a survey kind of a solution. And the benefits, again, the speed of capture, as you saw, it hardly took around 3 minutes to capture the data. The remote acquisition of data, high point cloud density. The scanner actually is capturing almost 1 million points per second. So you have a point, the point spacing between would be hardly a millimeter. So you get dense, accurate, photorealistic data with the scanner. Since the time is less, I'll just quickly show you the data which it has captured right now. So Lokesh, if you can help me. So as you see, we just need to plug the SD card out of the instrument and just place it into the software. You simply select the scan which was done, this first one, 3D conference, and you have the scan in here. I just load the scan here. Just filtering all the data that the noise, and I can show you the scan results. This is the scan that we just took. This is a grayscale point image. I can apply the pictures as well. Now if I show you a 3D view of this, so this is how quickly and how easily you have captured the whole room out here. And whatever you're seeing on the screen right now is all points. This is simply a large number of points which have been very closely packed, and you can do all kind of measurements on this. If I just need to do a length measurement, I just select the point part of it and select any point. So basically you get the distances. Now I say around 14 meters here. So this is something that you can very easily do. And I think the time is running out. If I just can get 1 more minute, probably I'll show the color rendition part of it. Just a second. So I'm just applying the pictures that were taken by the scanner, so that the exact imagery in terms of the photos that the scanner has taken also gets superimposed on this point cloud. So you get what you see is exactly the scenario which is there in the room. So this is what you're seeing right now is a colorized point cloud. This is not a photograph, it's a colorized point cloud, and you can actually measure any feature that you want to do. I mean, if I just do a selection, I mean the height, it would be around 4.427 meters. So anything and everything you're seeing is based on point clouds. Every point has an XYZ coordinate, an intensity value, and also an RGB value with the inbuilt photo capturing ability of the scanner. So I would also be very glad if you can come over to our booth if you have more questions to ask. We are there, me and Lokesh, basically he's our application engineer. We would be glad to take your questions and try to give you proper answers. Thank you so much. Thank you so much. Thank you.
Very good. Our next speaker is Vikram Chasarotia. He's the Business Development Manager from Lyco Geosystems, and he will have 20 minutes to speak. Thank you.